This conference will now be recorded.
Right. So guys, first let me try to give you a bit idea of what exactly White Tiger, how it is going to protect the data in terms of unexpected shutdowns. What happens, how the data recovery happens, we will see that. Before you see it, see every server with comes with a journal file. What exactly the journal file basically? So let me show this. cd var data, sorry, MongoDB data, right? Slash MongoDB data. If you go inside the data directory, there is one file, one directory called journal. This journal. So the journal file actually is used for the at instance level, not at a database level. It is a log file for the Mongo. It writes all modification into that file quickly. I'll show you in and out of this. This is very important concept. You all need to understand this because this topic is going to, like interview point, especially they would ask you a lot of questions on this one, especially on journal. Why? Because without a journal, there is no recovery. You see here, there will be three log files. Two are the pre-allocated logs, and one is a normal allocated file. This will be the one which will be used for the writing all the events of the Mongo. And by default, here three files will be there. Two are the pre-allocated log files, and the other one is the normal log file. This is, like it will try to fill up all these three. If that one is filled, it'll try to create one more file, one more file. Each file is 100 MB. If you calculate this one, this is a general file I'm talking about. Today, the discussion is about most of the things are about the general file. How data recovery can happen in the background if the Mongo is all of sudden shut down, and where it will pick up the data, the data gap, and apply to the data file. Same like in RDBMS, we have a database concept. Every database will have the log file. Even if the server is abruptly shut down, it will pick up the pending data from the log file. But each database will have its log file. In Mongo, it's not like that. Journal is a log file for the whole MongoDB. There is no database level log file. All databases will use the journal only for recording the write ahead log. Write ahead log means, let me explain this now. See, assume a case, this is a general file. Try to follow a lot of scenarios I'll try to cover. If you try to follow, it is simple to understand. This is a Mongo D server, and this is a Mongo data file, assume a case. And here, there's something called a checkpointing. Checkpoint, what it does, every 60 seconds, checkpoint will write. There's a checkpoint in Mongo. Checkpoint will run two cases basically. Checkpoint. This was a question asked by Guru yesterday, so this is the answer. So checkpoint will run every 60 seconds. Okay, seconds, or 2 GB of data is filled in the log file. Two situations, it will trigger the checkpoint generally. So this is a Mongo D. Mongo D means actual server where it is receiving the traffic and doing the operations. And this is a journal. Assume a case, this is a journal under the data directory. By default, it is data directory only. And this is a data where data means all these files actually. These are all files are writing. And each file, how do you identify? See, right now, how many files we have if you see? So 3, 4, 5, 6, 7, 8, 9. Total 9 files we have here. So if you see, observe closely. Three files. See here, 3, 4, 5, 6, 7, 8, 9. Now what I'll do, I'll go to the Mongo. Okay, I'll go to from this session to show you that because already there, right? Mongo. Now go to any database, doesn't matter. Use or show DBs. Use SQLDB or MongoDB, whatever it is, doesn't matter. Come on. Right. Show collections. Follow closely on this one. We have two collections in it. So I'm going to create db.create collection. Or else I'm going to, instead of creating, I'm just inserting some data called db.class, insert one single record just for the sake of the file generation. It will generate a file. Every collection will have two files. That also, let's see this. It will create two files. Every collection minimum will have two files. One is the data file, one is the index file. Every collection will have one default index. What is the default index? How it is going to help us? That comes in the indexing. We have performance tuning, in detail of performance tuning anyway. If you see this also, three file, 4, 5, 6, 7, 8, 9, 10. Okay, this seems some extra indexing file is created for, let me see. Then 3, 4, 5, 6, 7, 8, 9, 10. Maybe one collection has two indexes. It could be possible. Every index will have its own file here in the background. We'll talk about that. First, let's work on this data file. 3, 4, 5, 6, 7, 8, 9. And these were 10. It will become 11. This will become 10. If I create this single collection, let's just observe it. If I hit this, there is an extra collection on the MongoDB database, right? MongoDB. Show collections. Every collection will create a physical file. I'll create a class collection. If I go and check here, where I am right now, cd, cd dot dot, because I need to enter into the this directory. Now, if you see three files, 4, 5, 6, 7, 8, 9, 10. One extra file is created. The index file you see previously 10, now 11 will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why I'm showing all of this basically for you. So every collection will create a independent file. That's how collections are independent in the Mongo. One collection, if you are writing one collection only, will be locked. It won't lock the entire database any point of time. And also it is picking the what portion of data you are trying to modify. That data it is taking the snapshot and modifying, applying back when it comes to the concurrency in the white tiger. If it is a mmap v1, it will log the entire collection for the modification. So other people have to go to wait only. There is no other option for them. They had to, first transaction has to finish action on the first collection. Next will come in the queue and then pick up the lock once the first one is done. So that is something called collection architecture. So whatever you do now, all of these collections, whatever operation you do, first it will write into the journal basically. So now let me show you this. So MongoDB will receive the all connection, all requests basically, right? MongoDB is responsible because server service basically. All people are hitting the Mongo. What does it do? So you have a lot of databases in Mongo. So each database modification first, where it writes before it gives the confirmation to the application, first it write into the journal. Every see there are one is a two are the pre-allocated log files by default, and there will be one extra log file will be created by default. Three log files by default will be there. Each one is equivalent to 100 MB. This one, each 100 MB only by default. Once 100 MB is filled, it will create one more file, one more file, one more file like that up to 2 GB. See guys, try to follow this very closely. This is very important to understand. If you don't understand this, there is no, you don't understand the recovery in the Mongo. Oh, checkpoint interval is 60 seconds or 2 GB of general file. So before checkpoint runs, assume case in 60 seconds, if the journal is filled with 2 GB, because you are writing lot of data in Mongo and it can fill up the 2 GB journal file quickly. 2 GB means 20 journal files it can create. Each one 2 GB means 2048, right? Basically. So each file exactly 100 MB. If you take it this each file is 100 MB. Once 100 MB is filled, one more file, it'll keep creating it. If it reaches 2 GB or 20 log file or 2 GB, the checkpoint will trigger automatically, and then once checkpoint is triggered, whatever data is written from the journal file, it will get flushed out automatically. Only three log files will be left at any point of time. See guys, this is anyway you don't understand at one point because I had to talk a lot, then you get the full clarity. Journal is a log file for whole MongoDB server. Whatever you do, it will write in the journal first, then give the confirmation to the application. So even the Mongo is crashed for any reason, Mongo knows which transactions are committed, which transactions are in middle basically, because it is writing in the journal. Then only if it is able to write in the journal, then only it will give the confirmation. If it is not able to write into journal, the Mongo will not commit the transaction. It will throw the error to the application. So write ahead log. First data is getting written to the journal, and journal is recording, it is acknowledging, then the MongoDB will give acknowledgement to the application that okay, this transaction is finished. So now journal files are keep creating as the data is keep coming in at some point, okay, and before like 60 seconds, it did not fill up the 2 GB as in my case. Only 6 log files are filled up. Then when checkpoint occurs, what happens? It will write all of its data content, and once data is written, it will become invalid. It will become invalid. Why? Because the content of this log file is written to the data file already. So once it is hardened, this will be picked up back. I mean, it will keep only 3 files all the time once the checkpoint is run. It will claim all the empty files back, and then it will keep all the time 3 files. Let me show practically that. So try to follow the diagram discussion and the what I'm trying to show. If I go into the journal, how many files we have by default? 3 files by default. By default, two are the pre-allocated logs, one is the actual log. These are created to instantly not to grow this log file. At least it has 300 MB scope right now. If you see this value, let me open the Galaxy. This value is in KBs actually. So I'm pasting here. Okay, this is the value it is. If this is a KBase, I wanted to bring it to, it is in bytes actually, bytes divided by 1024. Now it is KBs. If I divide into 1024 KBase, then 1024, you see the value is 100. So total 100 MB file it is. KBs, sorry, bytes, KBs, MBs. That's how it is, right? So it is exactly 100 MB. Now,
So
what I'm
in general,
good.
it can be considered like a general is going to be maximum of 2 GB.
Yes, maximum of two. Exact point you made. It is going to be maximum of 2 GB only. Why? Because every 2 GB, if it is filling up with 2 GB for any reason, checkpoint will trigger, and it writes all of the content of each log file, and it will flush out the log file once it is written. So it will recycle every time it tries the checkpoint. It will only keep 3 files. How does it keep? Just let's see the practical also. Why to say kind of? Just see. There is some commands which will log the entire Mongo. Let me show this as well parallelly. This is where we'll see the log files are generating. I cannot generate 100 MB data to see that one file got created within a minute. It takes time. So in the live you definitely see that situation. But here I'm just trying to do this Mongo service. I'm running just Mongo. Anyway, what I'm going to do, show DBs, use MongoDB, whatever it is, right? DB show collections. I'm going to read some data, and it is letting me read. I'm going to do now Mongo is open. db.customer. Okay, let me go with the lab maybe. db.lab. Find. We have one record. If I wanted to insert a new record, I'll keep inserting it. Why? Because Mongo will accept, because general everything is fine. Everything is allowed to write now. So its name. I'll show the one situation. I inserted this record. We can do all operations. So I wanted to log all operations. There is one command we have, db.fsync lock. If I run this, Mongo will not let you to read write anymore in the Mongo. Whole Mongo will be locked. No one can write anything. See, now locked against writes. Use fsync unlock to unlock. So if I do the lock, it will create one extra file. See, it is created automatically. If I'm trying to insert here a new data, it won't insert because complete writes are blocked. You cannot write on the Mongo on any database till the lock is released on the Mongo. Fsync lock means when people do take the backup of the database, LVM backups, basically the OS level backup. That's something they used to run in the beginning days. So they used to take the only machine level snapshot. We are taking the dumps now. We are not using the Fsync lock anymore. But anyway, if I wanted to, I'll go to the Mongo. Now show DBs. If I can read the data when that server is locked, I can read the data. It is possible to read the data. So come on, db.log. What was that collection name? db.lab.find. I can read the absolute data. When the fsync log it is imposed, you can read the data, but you cannot insert the data. That is the problem with this. Okay, if I'm trying to insert again, it won't insert because it is locked completely. Till the lock is released, you cannot do anything basically. Okay. So now by the time if the checkpoint would have been triggered, assume a case, it will keep only one log file. If it is 1 minute, it will run the checkpoint automatically and it will claim the one first log file automatically and then keep the latest one by default back online.
Hey, Ravinder.
Yeah,
So, like in SQL Server, we have the database files as the NDF and LDF, right? So, in
right.
MongoDB, we have this only this the log files, which is called journal file, or is it only one, or the
Here only journal is a log file for the entire Mongo.
entire Mongo? Okay, got it.
Yeah. Just a minute, why this guy is not able to join? 1 minute. He's not able to join because link is not working. Just a minute, guys. Don't mind. Right. So for entire Mongo, you will have only this is what it will have. So now if I see by now, if the checkpoint is triggered, assume a case, if the checkpoint is triggered, the file would have been claimed. It is not triggered yet. Okay. It's not at 1 minute that I did this operation. Okay, it has to release this, I guess. I need to release the lock to run the checkpoint. Why? Because till that time everything is freezed. Even checkpoint is also freezed. If I wanted to unfreeze this, what I have to do? db.fsync unlock. Fsync unlock. If I do this, now the modification was hanging out. It will finish basically. See, it was waited for such a long time. As soon as I do the fsync unlock, it is finished the transaction automatically. So now you see that lab collection. There will be 3 documents right now. Now if you just wait for a minute here, you just closely observe it, then uh, there are 4 log files under the journal right now, and checkpoint runs and writes the data. Oldest log will be flushed and deleted. One will be left behind as a it has to keep one log file, and this log file will latest one it will keep and the oldest one it will delete basically. Okay. Latest it will keep, the oldest it will delete basically. Okay, so wait for this to done and then I'll pick up one more cycle. So that right, see, this file got flushed. We had 2 log files along with this. If you exclude the pre allocated logs, don't count this for now, only count this. So now intentionally what I'll do the multiple times fsync lock and unlock to generate the locks. So this one is created. Now you cannot write it. So if you're trying to write, you cannot write it anymore. So it is just hung. As soon as I unlock that one, it will let you to write again. See, it is written. Now again, if I lock again and if I try to read, I can read it though it is locked. If I'm trying to insert again, it won't do. Why? Because you locked already. So I'm just creating the situation to show that. So unlock again. As soon as I unlock, you see the lock file data got written. Again, few times I'll do it this. Why? Because it will generate the lock files.
So Ravindra, when it is in a lock state, and if you are trying to insert some data, it is in a
Uh,
hold state. So it shouldn't be considered as an drawback of Mongo because it should be terminating that transaction rather than committing after or unlocking it.
See, it will hold in the back end. In the front end, it won't even accept, basically. It just hangs there and it will time out basically for the applications, it is just, spinning off. They themselves cancel it, the queue, or else they'll have to wait. If the Mongo comes, it will pick up and it'll give the confirmation transaction is completed. It will spin the wheel for them anyway. It seems it is claimed. We had up to
Is
two,
there any default
six.
limit for locking? Is there any timeout? What is the default timeout value for that? Definitely.
For default would be 30 seconds in any most of the products, basically. Sync lock, just a minute. Unsync
So
lock,
every
unlock.
record it creates every one journal file.
No, 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 not every record. Not every record. It is
So is
going
it
to be
okay?
not every record. All right, see, now this I'm going to conclude this, guys. If you understand this, I'll explain through the diagram here onwards. So we have 4 journals right now. And if you see, there is fsync lock is applied this moment. Now I cannot do the insert. It just waits. I'm doing in the back end, not from the front end, first of all. So when it is a front end, it will not accept any write operations during the fsync lock. Just waits. It will spin the wheel forever. It does not give error, but it will spin the wheel forever because server is not completely unavailable. It is available, but it is not letting it to write. That is where the people will wait. As soon as the lock is released, the action will be submitted if they are still on that submission. If they cancel it, it won't pick up that query. So fsync unlock. So as soon as I do, it is inserted. Now you see the lock. If the checkpoint is occurred, what happens? Checkpoint happens. It will delete first 3 log files. Why? Because the oldest will be. It will write all the data, all content of this log files into data files, and it will pick up. It will leave the last file back online. So these 3 log files will be flushed out. Why? Because their data is written. And Mongo, it will keep every checkpoint. It will recycle all the log files if it is written the data, all of the data to the data file. Why? Because they are useless now. Because the data is written to the data directory, data files. Data is hardened. Now we don't need these log files anymore. Kind of. So it's a recycling. It is simple recovery model in the SQL. We can see it got removed these 3 files. What is it is left behind? The latest one all the time. This got left behind, but other files are cleaned up automatically. Now come to the discussion closely. Try to follow this, very important. So as the data is keep coming into the Mongo in the background, it is going to fill up the 100 MB file. If this 100 MB file filled, one more 100 MB file, one more 100 MB file. How many maximum it will create? 20.
20, 20.
Why 20? Because checkpoint, there are 2 conditions to trigger the checkpoint. This is a checkpoint. Checkpoint will trigger either 60 seconds or 2 GB. If it is created, 20 log files or journal files within the journal directory, checkpoint will trigger irrespective of the seconds. Like if the 20 journal files are filled within 30 seconds, it can happen. Why? Because you are keeping one general directory at server level, not at database level. So a lot of people are doing a lot of operations. These 20 general files can fill up within 60 seconds. It is possible. If that happens, so scheduler will be skipped and this will be validated. 2 GB will be validated, checkpoint will trigger. Once checkpoint is triggered, whatever the journal is written, and it won't flash out that way. It will go through all the journal files. Everything is written till the end of the file. And then it will acknowledge that, okay, I received all of your data. And then it will signal back to the journal that, okay, you flush out one by one. You don't need any more your files because I got the data. There is a situation, and more situation you need to understand. It is created the journal files because data is keep coming. Very important point I'm making right now. If journal is getting written, the checkpoint has triggered, and it is 2 GB data, it takes at least few seconds to upload all of its data directory, right? So it started writing the, see, 60 seconds or 2 GB, whatever it is, 60 seconds are happened, Assume, it will start right from the first file. It is writing. So second log file is written, third one is written, fourth one is, fifth one is written, and sixth one is written. Now someone has all of it shut down the Mongo. It is writing the data from the general directory. It has write 6 log files, and before it reaching the end of the log file, general file, all the 100 MB files, it got rebooted. Someone is did some OS patch, and someone has done some activity without informing us. Basically, if they inform us, will maximum count of general files are 20, generally 20. 2 GB means 20, right? You just keep, yeah, 20 general files it will create. Maximum of, you will have a 2.2 GB general, including pre-allocated. There are pre-allocated log files. If you that include 2 point, the general maximum capacity generally is 2.2 GB. It won't go beyond it, basically. If it is going beyond it, there is some problem, which means that set point is not going on in the background. It must be enabled. So you don't need to enable it as a default one. Okay, so now try to understand the situation. This is one of the scenario I'm explaining actually. If, see, there is a previous checkpoint is successful. CKPT, checkpoint means it is successful, it is written all the logs and flushed out. Next, second checkpoint is running. Just assume a case, second checkpoint, this is second checkpoint situation, what I'm explaining. CKPT 2. During the second checkpoint, it is written up to 6 log files. Then someone is abruptly restarted the Mongo. So Mongo does not read these writes as written. When the Mongo comes online, all the files are there. See, when it reaches till the end of all the log files and return to the data directory is okay, received all the changes, and it will signal back. Then it will start, like flushing out the general files, keeping one behind. But in this situation, what I'm explaining is, it is written up to 6 general files, and Mongo got shut down for some reason, abrupt shutdown. So in this case, this checkpoint is not a valid checkpoint. Not a valid checkpoint. Why? It is written up to 6 journals only. Other journals also are not written. When Mongo starts, again it will start recover from the beginning, and it will write all of its data and back to the data directory, and then flush out all the log file, keeping one log file behind. So it does the self recovery right from the beginning of the journal. So where it is left off, it will start from the beginning again, because Mongo does not write where it left off. There is no journal till what journal it is written and where it is actually stopped the action. Even shut down the Mongo, it does not write much of the journal information that is bad in the Mongo. We cannot do anything. If you go to, let me show this, where it will write journal is written or not in the log file generally. Cd dot cd log. Let us see. So you see this one, this is a file mongodb log, and wcl mongo log, how many rows? 241. We can read comfortably, not an issue. See, this command I use many times for any file. How big or how small? I'll see first number of lines. How many we have? Is it small or big? If it is too big, go for the filters all the time. So I can read it directly. This is what you have. So if you see here, do you see any journal files? Actually, if you see the journal files format was like this. We have seen, right? Where it is. Okay, sorry. Here we have. Where I was showing the journal files? Here only, right? Just a minute. Right, this is journal file. If you see, this is white tiger log dot. This is the journal file. Does it have this kind of entries in the log file? We'll see. This is a very big one, right? Let's see if it is written and flushed out. If it is writing, we can find it out, but it won't write as far as I know. Cat is fine. Grep, I'm grepping it. Grep, and I'm going to filter on that keyword. If I do this, there is nothing is written. So nothing is written means it is written the journal file. It is flushed also. We have seen it is left only the last file is a 9. So it is not writing any event in the log file that journal is flushed and it is returned to the data directory. And if it is crashed, where it is left off, that you cannot troubleshoot. Anyway, Mongo knows internally to write all of its data back to the data directory when all of a sudden it's abruptly shut down. But we cannot troubleshoot where it left off, where the data is pending to write, in which journal file it was failed to write the data because abrupt shutdown. We cannot troubleshoot. Only that is internal recovery system does. It is system job, not your job. But most of the time, Mongo actually they would have done this enabling. Journal file login should have been there. It should have been there in the Mongo log events log. If it is there, we'll come to know how many journal files are there and where it is actually stopped if the abrupt shutdown happens, right? That is helpful for DBBus that the information is nowhere recording in the Mongo. That is a bad thing anyway. But internally, what is happening, you need to understand, guys. Checkpoint is responsive. See, all of whatever you do on the Mongo, first it record in the journal acknowledged. By default, transactions are journal acknowledged. That is a MongoDB nature. What does exactly journal mean? Acknowledge means. First, see, if you are triggering a transaction, first data will come, data file to, it will come into the memory. In the memory, the transaction will take place, modifications, whatever you. If it is written in the memory, first it will write into journal. If the journal is written and acknowledged, then it will give the confirmation to the application. This is architecture, actual architecture. If you are submitting an action to Mongo, MongoD does not have the data directly. It has the data in the disk. It will read the data from the disk to memory. In the memory, the action, whatever the instruction you have given to Mongo, it will do in the memory. Then this will become a dirty data. This dirty data will be written to the journal first. It is a background operation anyway. It will write into journal. Once journal is written, it acknowledges, okay, I got the data into journal. Then it will give the confirmation to the application. So it is called journal acknowledged. Journal acknowledgement. Journal is giving the acknowledgement that I have received the change what you did and give the confirmation to the application. For any reason, for any reason, whatever the data is written in the system may not be in the data file, but you have in the journal at any point of time. Becoming confused, following, say something.
So even after the shutdown process happens, still the data exists in the journal file, and whatever the checkpoint becomes invalid, it starts from the beginning because the data exists in the journal all the time.
Exactly. You summarize the whole thing actually. That is exactly the same point we need to understand. Very good summarization actually.
Yeah.
If you see the diagram now, come to the slides. You need to understand the situation. I'll explain the slides. Just try to follow. See, write operations are going on. All write operations on the MongoDB will write into the journal. Checkpoint to 1 is triggered, it is finished. Once the checkpoint 1 is triggered, finished, it will clean up all the journals. And if you see the checkpoint 2, if checkpoint is triggered but it is failed in between, it will write from the beginning. This checkpoint will become an invalid one. This one was a successful one. So whatever the transactions are written after that checkpoint, it will write from their beginning, from the beginning. So if you understand these words, I can start with the slides. Any questions on this architecture? Any way you have question, let me know. If you
So
understand
that
the situation,
means there is no data loss here in MongoDB. So
as
is it
long as
possible?
long as
Yeah,
yeah,
yeah, go ahead, go
as
ahead.
long as long as this general file is not corrupted, you don't have a data loss.
Okay, okay. So basically, because of some kind of power thing and all that, there's no data loss. Only thing that during the process of the power shutdown is the what we have kind of a loss because of the power shutdown or whatever is the reason.
No, whatever it is, we don't. Yeah, when it brings online, it will pick up the data where it left off.
Okay.
So even you don't lose the data. Power off means you are not reading, as simple as it is. Whatever the state, it doesn't matter to the system. Why? Because nobody's reading it. When system boots up and when you start the Mongo, it will pick up all the pending data and write into the data directory, and it will come with all the data.
Okay, okay.
So what happens
How
to the
about the
general?
caches?
So what happens to the general files? Does it overwrite from the beginning, from checkpoint one onwards, or does it skip
Yeah,
those six?
after checkpoints, last successful checkpoint, whatever the data written after the journals are generated, all the journals are written back to the data directory. Then it will start flushing the journal files. It will start from the beginning of the journal to start a recovery of the data. Which kind of scenarios journal will corrupt? Voice file, you cannot say that which kind of scenario. Maybe hardware crash, some journal file is not readable anymore because that segment, the sector, it got corrupted where that journal is sitting. uh, that I never seen anyway. But if you have that kind of situation, we need to have a oplog replication concept to recover the data. If you really have that kind of situation, you have proper backups there. And here in Mongo in terms of recovery is very weak. If one of the journal is corrupted, Mongo does not go down. It will pick up the rest of the journals and come online. This will run with the one journal data gap by default.
Is there
That is
anything
also
like log sequence thing? Like for example, in SQL Server we have LSM, right? So is there
it will
something?
follow. Yeah, good question. It will follow checkpoint sequence, not the log sequence. Till what checkpoint sequence is followed, next will pick up the next sequence. We will start in the journal file that knows internally. Checkpoint sequence, the last checkpoint sequence, and next immediately whatever is started with it, it will pick up the data from there. It is not log sequence. It is checkpoint sequence here.
Checkpoint sequence we call it here. Okay, so
Yes.
during the checkpoint sequence, like one of the log file gets corrupted or something happens, so then like what happens?
Actually, if that is the case, if something is corrupted, something, I assume a case, anything can happen like in the world for someone. If
Right.
this is corrupted, it will skip that. It'll come online with the rest of the data automatically.
So during that time, it doesn't matter about the checkpoint sequence.
Sequence, it matters, but it will come with all the available data first online. It has to look for, okay, the successful is this one, this is a failed case. So where it left off, it will start from there automatically. And if some journal file is not available, still it does the recovery with available journal files and comes online. That is a Mongo nature. And it runs the with this journal file data gap. And if you don't figure it out, that will be there, the gap will be there forever.
Okay.
That is how it is. We cannot do anything. The product is made like that. That is where Mongo is weak in terms of recovery. It does not look for the data gaps. In many scenarios, Mongo runs with the data gap also. In other technology, we'll see. I'm going to talk about in the backup recovery. In standalone, if someone deleted a data, there is no like log backup concept, only full backups. We don't have differential log, it has subsequent log backups. We cannot take in the standalone servers. Only in the replica set, we have a full and off log backup, log backup. Differential backups are there, not there. We will see where we get the full recovery, where we cannot get the full recovery is a backup restore topic. Where the Mongo is really weak in terms of recovery, I'll pinpoint that. That is a different story for us. This is something self-recovery of the Mongo what we are discussing. Because of any abrupt shutdown, the data is still is there in the journal. From the journal, it is recovering the data whatever is not there in the data directory. That you have to keep in mind. Let's conclude with the slides. So where are we now? Right.
So one
Right.
question, Ravi. So
Yeah, go ahead.
how about the transaction in transactions? Say something, if a transaction is in the middle and it is did not committed, so whether
See,
that transaction gets rolled back or
your point is very good. There is no rollback in the Mongo. No rollback concept in complete Mongo. No rollbacks are not there at all. You write a batch, assume a case. You write a batch to modify the data 1 to 1000, assume a case. Now it is written up to 500 records and then it is failed. Written means written. 500 records are committed. And what failed? 501 to 1000 are failed. When they have to insert, they have to verify how much data got inserted from where they have to start. There is no rollback concept in the Mongo for the transaction, though it is batch or normal, whatever it is. Inserted means inserted. That is implicit. What do we say? Commit. Implicit commit. There is no batch that it is left off means it will roll back. There is no roll back in Mongo. Whatever it done till what point it is written. That's it. You have to verify, re-verify when if it is failed till what point it is executed. Where I have to start again. That way they have to verify.
the same
Does that
thing,
answer your
for
question?
example, of booking a ticket?
Yeah. Booking a ticket, kind of, we cannot say why, because booking a ticket you have a rollback. If someone is actually booked it, sometimes it happens, you get the acknowledgement that again if the amount is reversal. Kind of booking ticket is also work, but here it is direct commit. See, booking a ticket, when you are booking a ticket in the website, you selected a seat or something, it will lock for you, though you did not made the payment. It will lock for some time, like 1 or 2 minutes. Within that, they'll tell you that your session you have to book within this time, else this will be released. Kind of. If you don't book within that time, the seat will be given to someone else. So it is just a lock, temporary lock on that. That is different story. That is works in the RDBMS, not in the Mongo. Mongo does not have the rollback methods. Whatever is executed in the batch, executed, that's it. There is no rollback concept. And if you wanted to run the same batch again, you have to see till what point it was executed before it failed and start where it is left off. That is your responsibility in Mongo. That is architecture. You cannot compare 100% with the RDBMS, all the things. Does that answer your question?
Yes, Ravi, yes.
Santoshi?
How about the
Yeah.
update concept works here? Like it is reading from the data from the data files, and how does it is fetching the data?
See, any kind of product, this update architecture is same. So you instruct Mongo to update, but the Mongo what it does, okay, what you instructed, it will go to the disk subsystem and get the data with the either it will go with the collection scar or index scan to get the data more efficient way. That is a different story. We'll see in the performance tuning. Once data is loaded into memory, then it will start updating. Once it is started updating, write into the journal and give the application. The confirmation update is finished. Once journal give the acknowledgement about each transaction.
So yes,
This is
there
how
is
it
no
is.
concept of archeologins, right? So once it is flushing into the data, so
No archive.
it always clears the
No.
two general files.
That's it. It just we have seen the situation, right? What I was showing, these log files are flushed out. One only was left back online. See, that is why intentionally. See, I created multiple fsync logs. I created 4 log files. Every fsync you generate will create extra log file, extra journal file. And when the 1 minute is over, checkpoint is triggered. The old log files are flushed out because the data is written. It is empty or not empty, it will go through that file, and if data is there, it will write. If not, it at the end of the checkpoint, it will clean up the old log file and keep the latest one as back online. One file, 2 are pre-allocated, one only will be left off after the checkpoint. There is one more situation you see. One more situation you'll see is you see even after the checkpoint more log files. It happens. I have seen that. How it happens? Quickly. See, you have a lot of log files, 2 GB log files. Assume case 2 GB are written. To write the 2 GB takes some time. See, it is started here. It is writing all of the data to this one, this one, and this one. It started writing to here. When it is writing, okay, by the time, by when it is writing, basically, the other transactions are also going on. If others are coming and writing that data, so the checkpoint sequence where it started, it will pick up that, and it is written and 2 GB. Let me show this. Like up to 20 files, it is going through writing it. So by the time some transactions came and then it is written. It is written means it is unmarked. Okay, this data got written, data got written, data got written. Once it is written, it is actually treating that okay, this is unmarked kind of. This upcoming transaction will start writing the data back to the journals, pre-allocated journals, especially pre-allocated journals. Upcoming transactions, see, these pre-allocated journals are given that purpose. Pre-allocated journals are given when the checkpoint happens. When the checkpoint happens, these two are open for writing it, the pre-allocated journals. When it is writing the checkpoint around 20 files, that doesn't mean that everything has to be locked. It has to write the upcoming transaction details in the pre-allocated log, basically pre-allocated log, and during that time it will trying to write all of its data and come again to form the sequence, next checkpoint sequence, because this checkpoint is finished, next checkpoint is also finished, next checkpoint till next checkpoint, whatever the data is writing in the log files. See guys, there is something called pre-allocated logs. Why pre-allocated logs are given? This is not for normal operation. When the checkpoint happens, checkpoint writing the data, that doesn't mean that you are holding off all the upcoming transaction till the checkpoint is finished. During that time, it writes all the logs into the pre-allocated logs. At least it has a 200 MB scope basically. So it happens, in the background system will take care of what transactions are written, what transactions are not written. Based on the transaction, it will form the checkpoint sequence. From there, it will pick up in the background, basically. I guess you followed or not followed, just let me know. Pre-allocated log
Sorry,
functions.
last one more question. So can we increase the checkpoints, like it is by default 60 second, or it is like 2
Default.
GB?
It is default.
With
You're
the
not
default?
default. This is a default one. It comes with the defaults. Basically, we don't change these values. I never seen this
Even to
default.
improve performance or okay.
Yes, if you trigger too frequently, basically, if you trigger too frequently, maybe some issues with the architecture. This is architecture. This is how the Mongo is made, and we don't touch these values. I mean, checkpoint values. I never seen changing these values in my career. Basically, this default will keep
Okay.
it that only.
Yeah, in DB2, like how it works is like we can increase the transaction log space if it is getting more files, right? More
Right?
transactions, you can increase the space.
No, no, here we don't give it. 2 GB is
Got it.
enough. 2 GB. If you keep it more space and more one, maybe you're keeping the burden on the Mongo as the pending data, basically. If more pending data, more recovery it will take to come online when the server is rebooted. So all matters. This is made as the best standards by the product, basically. These are the best standards by the product. If you're deviating, you will see the consequences somewhere around, basically. Right. So I discussed till this point, if you guys remember, mostly yesterday. See, when writing to the disk, White Tiger writes all the data in a snapshot to disk in a consistent way across all data files. The now durable data act like a checkpoint in the data files. Checkpoint ensures that data files are consistent up to the including the last checkpoint. Checkpoints can act like a recovery point. This is what exactly I was making it. Checkpoint acts like a recovery point, not lock sequences here. Now try to understand. Next two slides are all fully dependent on our understanding what discussed now. MongoDB configures the White Tiger to create the checkpoint. Write the checkpoint onto the disk at interval of 60 seconds or 2 gigabytes of journal data. This is just the thing that what we are mentioning, this one, this part. that complete sentence. This one, during the write of the new checkpoint, the previous checkpoint is still valid. When the checkpoint is going here, till this is finished, completely finished, this checkpoint is the last reference for the system. Why? Because it will start again from there to write the data from the beginning. All these sentences are Mongo website. What I did not write some words which are very important words. I did not write. I picked up from the Mongo website. During the write, see new checkpoint, the previous checkpoint is still valid. As such, if the MongoDB terminates or encounters an error while writing the new checkpoint, see something happened, abrupt shutdown happened when the new checkpoint is writing up. So what happens upon the restart? MongoDB can recover from the last valid checkpoint. If this got interrupted for some reason, if comes online, it will start, what was the last checkpoint sequence, and it will start from there, writing all of the data to data directory automatically. So in case of this failure, this is a reference for the system to recover the data. So when it is fully completed, when it is fully given that all of the data, all the general files data, and flushed out all the general files, then it will become a valid checkpoint basically, right? The white tiger journal persists all the modifications between the checkpoints. Between the checkpoints, whatever the modifications have been done after this checkpoint, all will be recorded here. And once the next checkpoint is triggered, all of the data is applied and then flushed out again. So checkpoint to checkpoint, between the checkpoint to checkpoint, all of the data, 60 seconds or 2 GB, is sitting in the journal. That is anyway directly we discussed that point, right? So the white tiger persists all the modification between the checkpoints. If the MongoDB exists between the checkpoint, exit means it is shut down. It uses a journal to replay all the modified since last checkpoint. It is looking for the last checkpoint, whatever was left off from the last checkpoint, not left off from the last checkpoint. It will try to recover right from the beginning of the journal to last again. With the white tiger, MongoDB supports the compression for all collections and indexes. This I have discussed. Compression, it will follow always snappy compressor, and you have a glib also. Glib is not recommended because it's compressed really indeed, like deeper compressions we don't want. That will impact the system performance. So snappy compression is enough basically. Don't go for the glib. It is not recommended. So with the white tiger, MongoDB supports with the white tiger only, MAB1, you don't have a compression. With the white tiger, MongoDB supports the compression for all collections and indexes. Compression minimizes the storage used at the expense of additional CPU. Yes, you need some extra power of the CPU to compress it and decompress when you are reading it, but you're saving a lot of resources. You are saving the disk storage, you are saving the backup methodologies. Everything is dependent based on the background size. You're taking the backup, it is compressed, it will become a small one basically. So the background maintenance becomes simple with the compression basically. So compression is mandatory. With if it is MAB1, 100 GB means 100 GB straight away. The writes are faster. Why? Because it's not compressing it. System resources are not engaged basically. It is writing as it is data. So all will come with the pros and cons, guys. The new checkpoint becomes accessible and permanent when the white tiger's metadata table is automatically updated to the reference to the new checkpoint. If new checkpoint has to be as a like a successful checkpoint, when it is reaching the end of the file, writing it, and then it will make the entry about this checkpoint internally. That is what it is saying. New checkpoint becomes accessible and permanent when the white tiger metadata table is automatically updated to reference the new checkpoint. Once the new checkpoint is accessible, white tiger frees all pages from the old checkpoints. Once the checkpoint is written all of its data, it is done its job, and it is made an entry in the checkpoint that reference file, it will flush out all the general files. Till that time it will hold off this. Why? Because checkpoint has to become available like as a valid checkpoint. Till that time generals will not be flushed. By default, white tiger uses the block compression with a snappy compression library for all the collection and prefix compression for all indexes. uh, this we have seen already. Snappy compression. What is snappy compression? How much data? 5 GB data, it is directly compressed to 275 MB. 5 GB to 275 MB is basically 90 plus percentage basically it is converted to. That's something quite good. So whatever data you're seeing in show DBs basically is not the complete data, it is compressed data. So here, show DBs, you see it's 0, 0. It's not 0, it has some data at the moment. So, I mean, it can be 0 also if you don't load anything, but if it even 1 MB, 1 MB equivalent to can be 1 GB or else 800 GB, 500, sorry, 1 MB equivalent to 500 MB, 600 MB, 800 MB also. Why? Because it's compressed. Data will get compressed by default. Now, memory. So memory, I don't finish now. Mongo memory is it works in a different way. It uses two system caches basically. File system cache. See, with a white tiger, MongoDB utilizes a white tiger internal cache and the file system cache. Internal cache. Internal cache. See, MongoDB, how many indexes you create, all indexes is try to keep in the memory itself. It does not keep in the hard disk basically. Internal cache will be used for loading all Mongo indexes. File system cache will be used for reading the data. The data will come in the file system cache. The indexes data will sit in this internal cache. Why it is Mongo is trying to keep all your indexes in the memory? Indexes are the data pointers. If you need some data, it will contact the index and get the data. So indexes are sitting in the memory, directly can access the index and get the data. So we'll talk about performance tuning. There I'll pick up this. What is a memory point? I don't want to finish right now. Let's park this discussion there. What is the recommendations we do on the memory? What percentage of memory we have to give? I'm going to pick up an example and tell you. So this now, for this now, I don't want to take it up. No need to worry, memory management is not finished yet. We are going to talk that separately. Right, journaling. See, the journal is a log that helps to recover the database in the event of hard shutdown. Journal is a log at MongoDB server level, not database level. It is helping the Mongo to do the self-recovery in case of hard shutdown. Journaling with the White Tiger storage engine. So actually, it is mmap even, or also White Tiger storage engine, or also in memory. Journaling is there for anything basically. Journaling will be there by default. White Tiger uses the checkpoints to provide the consistent view of the data on the disk and allow the MongoDB to recover from the last checkpoint. However, if the MongoDB exists unexpectedly in between the checkpoints, journaling is required to recover the information that is recorded after the last checkpoint. The same thing it is saying. If checkpoint fails, it will refer the last checkpoint and get the data, all the data from that checkpoint. See how journaling work. Journaling, the recovery process looks in the data file to find the identifier of the last checkpoint. Searches in the journal files for the record that matches the identifier of the last checkpoint. Apply the operation in the journal since the last checkpoint. In case of MongoDB shutdown all of a sudden, it look for the last checkpoint sequence. From there, whatever the next sequence is there, it has to recover. It will start the recovery from there onwards. That is why I said even MongoDB has, you have 15 journal files, assume a guess. Just assume a guess. You have 15 journal files. It is written up to 6th journal file already, but it is failed at this point. Doesn't mean that it will write from this journal when it comes online. It will write from the last checkpoint sequence, right from the beginning. Okay, right from the beginning. That is what it says. Apply the operation in the journal since last checkpoint. Last checkpoint means the next sequence after the checkpoint. But before the shutdown, the last sequence is started. It is started up to 6th journal file. When it comes online, it will start from the beginning to make sure that everything is applied properly. Is it clear?
Ravi, one question, yeah.
Yeah, go ahead.
Ravi, can you show me that paint?
Okay, paint. Okay, fine.
So like, for example, if it is the fifth file is corrupted actually, okay, so
Corrupted.
that means next time the checkpoint, it's again start from the first, right?
First one, yeah, of course.
Yeah. Okay, so like for after a hour, the checkpoint will keep on going, right? So like,
this is interval.
every start from like
it will go on.
After, yeah, my question is like, if for an 10 minutes, for a 15 minutes after the checkpoint, so that the corrupted one, it won't going to release, right? So the checkpoint will keep on going, right? So like how it is?
See, if the checkpoint come to the end of it, it will try to delete all the one, leaving one, the latest one log file. It will try to delete, though it is corrupt, doesn't matter. It is skipped already. So there is a product. It has some that gap actually. Mongo should fail there itself. If it is failed, there is no recovery. There is no recovery for the data if the journal is corrupted. There is no backups for you to recover in the Mongo in the standalone. That is the reason they are not stopping you here. If they are stopping you, there is no recovery for Mongo. You cannot make the Mongo online at all. Why? Because corrupted means corrupted. You cannot build that journal file with any backup.
Like
There is no
so
build.
for example, we have a 10 journal file, so like a log file.
Mm,
So it's failing in the fifth file actually due to some
mm,
reason. It
mm.
won't go for the sixth file, right? Like
See, it will try to read the data as much as it can and then move to the next. As long as checkpoint system is everything is online, it does
Mhm.
not stop. Even the journal is corrupted, it does not stop. That is what I was already said. But anyway, so if the journal is corrupted, it will read as much data as it can read from it. It will move to the next. It does not stop there generally.
Okay. Yeah.
Recovery, it will do all possible data. It will recover and come online. If example journal file is corrupted, Mongo is not coming online, it never come online, as simple as it is, because you cannot build a journal manually from any backup. There is no backups for journal. So that is that there are gaps in the product. Still, that is the reason they are not, this is not used for the more critical data. Generally, corruption is
Right.
very 99, it's a very rare minute situation you might see it, but minute is also considered by the business generally. So MongoDB has a lot of sophisticated features than the RDBMS compared to, but still it did not overcome the RDBMS yet. Why? There are weak recoveries we have. So the recoveries compared to RDBMS, Mongo is weak in terms of recovery for sure. Anyway, I'll pinpoint all of this when it comes to the backup restore. No, don't worry. All right, if you see write operations, we discussed all of this, guys. All write operations will go to journal. See, journal. What interval it will write? That is also one more point. It will come here anyway. Every 50 milliseconds. See, this is a diagram we discussed already. The same diagram. What I discussed this way. The diagram is given this way. Checkpoint. So all the modifications written to the journal, all, and when it is writing from the journal to data disk, it is look for the checkpoint and write all the date, changes to the disk. If the checkpoint is triggered, if it is failed, it will pick up the data from the last checkpoint and apply back. That we have seen already. Journaling with the White Tiger Store Engine. White Tiger syncs the buffer journal to records to the disk according to the following. See, guys. White Tiger syncs the buffer journal to the disk according to the following interval condition. See, disk means you are modifying something. If you wanted to modify, what you need basically, you need memory. First, data has to be pulled into the memory. There, the modification, any product you pick up, this is architecture it follows. Data won't be there by default in the memory. You have to pull it from the disk subsystem and load data in memory, do the operations here. And when it is doing, how frequently it is writing to the journal? That is a question. How frequently is 50 milliseconds is a default. 50 milliseconds is a default scheduler. 1 second equal to how many milliseconds? Does anybody know? How many milliseconds? 1
1000.
second, 1000 milliseconds. So whatever the data writing from the memory to disk is a 50 minutes, 50 milliseconds. ms, sorry, it's not milliseconds. Second itself is a blink eye of eye almost, but 1 second is divided into 1000 parts. Out of the 1000, 50 milliseconds, do you calculate this 50 milliseconds? No, it is simple. Even it is it's very quick basically. So when it is writing the data from the buffer pool to the journal file, every 50 milliseconds, whatever is the modifications are done, it is picking and writing into the journal after 50 milliseconds the scheduler in the background. There is a scheduler for that. So that is what this is saying. Every 15 milliseconds, the data will be get written from the buffer pool to general data. General data means general directory. MongoDB sets the checkpoint to occur in White Tiger on user data at interval of 60 seconds or 2 GB of general data has been written, whichever occurs first. Either it can be 2 GB is filled out before 60 seconds, it will trigger the checkpoint, or before 2 GB is filled up, like 1 minute is over, it will trigger the checkpoint. Whatever the thing happens first, it will pick up based on that. If the right operation includes the right concern, JTrue, White Tiger forces the sync of the White Tiger general file. We will see the right concerns. We have right concerns: memory acknowledgement, general acknowledgement, replica acknowledged, and multiple replica acknowledged. There are acknowledged. You had to mention it transaction level so that the acknowledgement mechanism will change in the background. It is a transaction level. We will see that what are the types of acknowledgement transactions we have, how we use that. Basically, we have the discussion on that one in the replica set. Because MongoDB uses a general file size limit to 100 MB, White Tiger creates the new general file approximately 100 MB of data when White Tiger creates a new general file. When the previous when this general file is full, it has to create one more general to load the data. So it will create exactly 100 MB. So if you see these files, what I was talking about, all files are with equal sizes. They are not different. Come on. All right, you see? Do you see any difference between these file sizes? No, all are same sizes. All will be created with the 100 MB only. That is what the sentence is saying anyway. Right, White Tiger automatically removes the old journal files to maintain the only files needed to recover from the last checkpoint. It is flushing out every cycle. It is flushing out and keeping the new journals, whatever is the latest journal, to write the data from there onwards to form the next sequence of the checkpoint. For journal files, MongoDB creates a subdirectory named called journal under the DB path directory. If you see where it is created, by default, it will be in the data directory, as simple as it is. So, LS PWD first, where I am, log, come on. Data. If you go to here, where the journal got created under the data directory, only. It's like that. So it is here, journal file. It is following some sequence. Guys. If you see, the journal file has some sequence to write down the file name. Come on, see here, 6, 7, 8, 9. It is following the number sequence to follow the journal file number in the background, basically. That file format it is talking about, which is fine. So MAP1, this is what is the story White Tiger storage engine. This is how the White Tiger storage architecture is: writing the data to the journal and get the recovery through the journal, and based on the interval what we have discussed. MAP1 is little different, not exactly like this one. So let me talk about the MAP1 architecture first, then I'll talk about the slides. I'll try to finish this. We are almost close. See, the mmap even is completely legacy storage engine. No one is using in the Mongo world, most probably, unless until they are not part of the less than 2.6. If they are on 2.6, they had to run with the mmap v1 only. White Tiger is introduced in 3.0 and 3.2. White Tiger is a default storage engine for Mongo. These points are very important questions they'll ask you. So in 2.6, after 2.6, 2.8 is not there. We discussed the versions already. 2.6, if you're running the Mongo, then you don't have a White Tiger storage engine, because that time with that version, White Tiger is not introduced or acquired by Mongo. It is a White Tiger is not MongoDB developed storage engine. It is someone developed and they acquired it because it was completely fitting with the Mongo. They paid it and they got it and they integrated with the Mongo. But actual Mongo storage is different. It is really vast. But try to understand. journaling with the mmap storage engine, mmap v1 basically, we'll call it as. See, MongoD, this is the MongoDB server receiving the request, and all of the transactions are writing in the memory, which is called private view. The private view, which is a memory, writing all the transactions to general directory. Okay, it is simple. The same thing what the white tiger is following. Good enough. But whatever the transactions are written bring back to the memory again and played back to the data directory. It does not play from the general to the data directory. There is no direct communication between the general to data directory to sync the data. There is no checkpoint will use, but checkpoint will trigger from the shared view memory, not from the general. So if example, if I did a 1 GB modification, 1 GB modification will go here. That 1 GB again will load into memory and load into data directory. It is a two-phased commit. We'll call it as two-phased commit, MFV1 storage engine. Why? Because whatever the transactions you are writing into journal, again, journal data will be taken to the shared view of memory and writing to the data directory. So you need the double memory on this machine, not single. Why? Because you are handling data writes through memory again. It is already in the memory first. This memory is for the journal only. This memory for writing the data directory from the journal again. So you're pulling the data again to the memory from the journal and writing to the data directory, which is a really bad architecture. That is the reason it has lot of limitations in terms of memory. Also, it's a very bad storage engine. In terms of data management also, like it is directly writing all the data without compression is not supported, so it is going to occupy all of your disk. There are many disadvantages with the mmap v1. No one will use in the market because of the disadvantage it has basically in the architecture. Storage engine architecture will define the data handling basically. How data is written, how data is recovered, how data is stored in compressed format or not compressed format will define by the storage engine only. So based on the storage engine only, MongoDB performance is directly related, as simple as it is. If you go with the in-memory storage engine, it will give you the more performance, but more infrastructure cost is there in the background. You have to keep lot of RAM because everything is in the RAM, not in the disk. So based on what storage engine you're defining, the Mongo response will depends. Mongo architecture will different. Why? Because each storage engine has its own architectures, its own advantages and disadvantages. We always look for the more advantages than the less. Every option will have a disadvantage in some direction. So look for the more advantages, less disadvantages. So all that we need to look at. Now, if you understand, mmap v1 is the one which is following the same architecture for the white tiger itself. The bad thing with this is it is getting the data back to the memory again, committing into the data directory. So you need more memory power for doing this. Why? Because it is a two-phased commit product basically in terms of data. You guys are following this architecture? Tell me.
Yes.
So this is very bad architecture. That is why they bought someone else's and applying it. So MongoDB writing the private view. From the private view, it will write to the journal, and from the journal, every 100 milliseconds, it will pull into the memory and write to the data directory. Oh, it is 60 seconds only. From here, it is writing to private view to journal. It is 100 milliseconds, not 50 again. The interval is more, 200 milliseconds. Here, no checkpoint. Checkpoint itself is writing the data back to the data. Checkpoint is getting the data, general data into private shared view. From there, writing to data directory at interval of 60 seconds. The same thing. Every time it is getting the general data to memory, writing, and then flushing it out. The same architecture, but it is going through the memory.
So what is the difference between the shared view and this private view?
Private view is for the directly accessible by the transactions. Transactions are writing here and writing the journal data into the journal. This is responsible making the data recovery. See, if the Mongo shutdowns, this journal will be played out to get the data from the where it is getting the journal data from the private view. But how the actual data directory is getting the data through shared view. From journal data is loaded into shared view. From there it is writing to data directory. This is for the transactions. This is for the recovery.
Okay, okay. Separate threads to perform tasks.
Yeah, that is why it is called two-phased commit storage engine. Two-phased commit storage engine. because it's following two phases here in the memory. It need more memory. Why? Because for writing this data also it has to go through memory only, another segment of memory.
Yeah.
Clear, right?
Yes. Yes.
So with the we can use without journal also. Without journal, we can mention no journal in the config file. It will not build a journal file anymore. But now from 4.0, journal is mandatory. Like in below 4.0 versions, you can mention you don't want journal. If you don't want journal, you lose all of your data. If the system is abruptly shut down, it will always run with the data gap. It will run. Data gap is still there. Mongo will run. That is a bad thing. We cannot do anything. The architecture is like that. If you run MongoDB with no journal, what happens? It will write all the data to shared and writing to data. So as long as server is down, up and running, no issues. See, it is writing the checkpoint is 60 seconds only. If system shutdowns, the whatever the data was there in the memory not written to data directory, it is gone. Again, Mongo will start. No issues. Data gap is there. It is no issues. It will run. Mongo runs with the data gap. Absolutely fine. If there is no such thing, Mongo you cannot restart. It will just stuck there only. There is no recovery. You cannot build the journal file manually. Should be built by the system only. So Mongo.
Basically, when there is no journal file and then there is a system shutdown or something, then we cannot get the data back
Right. That's
because
correct.
because if it is not returned to the disk and it's still in journal and there's a shutdown, that is gone.
There is no journal. Everything is in the memory. The memory will be flushed out. It is a temporary. When the reboot is done, the everything is vanished from the memory. So no recovery. Still it
Yes, so
runs the Mongo. So this is in the pre-prod we use this, but nowadays we are not using anywhere. We used to in the olden days, but no one uses the without a journal. Journal is
yes,
mandatory.
I was thinking, what is the advantage of not having a journal? So
Advantage is that you don't want some system to manage this journal unnecessary load on the system. Just keep it as it is. Whatever you, if it is a pre-prod, your test machine or something you don't want journal, just don't keep it. It won't load the machine much.
no, okay.
It runs
Yeah.
with the data gap. Whatever you load, that may be written or may not be written. There is no guarantee.
So is it like faster in terms of
Damn fast.
performance then
It is. It
because
is.
of no
It is
journal?
damn. Yeah. See, it will acknowledge from memory itself. Does not wait for the journal to write
Yeah,
and acknowledge.
right,
So
right.
it
So
is
that,
fast.
yeah. Mhm.
More performance, but data loss.
Yeah, exactly.
Right. So let's talk about. I'll finish this, guys, in 10 minutes. If you understand, these statements are simple. mmap v1 is the MongoDB's original storage engine based on the memory mapped files. So this is something is originally developed by the MongoDB. So it's not good anyway. It is excels at workloads with high volume inserts and read and in place upgrades. Basically, does not deal with the compression. That is why it is fast. Compression will come with the additional computing power, like CPU and memory is required for that. CPU power, not memory, for compression and decompressing the data. So mmap even handles the plain data. It is fast to read the data, write the data. It is fast. Why? Because it is not waiting for the compression and decompression. In the default configuration for mmap v1 storage engine, MongoDB writes the data files on the disk every 60 seconds and writes the journal files roughly every millisecond. So what it is saying is this one. And the private it is writing the data to journal is 100 milliseconds, but from the journal again the same flow, like 60 seconds or 2 GB from the journal to data directory. That is what the statement is saying anyway. All right, writes the data on the files every 60 seconds, writes the journal files roughly every milliseconds into the journal files from the private view. With mmap v1, MongoDB automatically uses all free memory on the machine as it cache. It required lot of memory because of the two-phase commit. Whatever the memory you deploy, it will lock all the memory if it requires. Like you need a two-phase commit, it requires a lot of memory. It will catch all the memory if it is free, if it is required by the operations. It will catch on you have 1 TB, you have 2 TB RAM, still it will catch all the memory if it requires. If it requires, that is the story.
Is it
So
can it be controlled, the memory usage?
yeah, actually this is a
Like,
shared view
like
only 2 GB, right?
you can
Two
say
shared
that.
view.
No, you said that it can take up all the memory of the server, right? So you can
Hmm.
keep some memory for your operating system and some memory you can use it for your MongoDB. Can you control it that way?
You should not control. If you are controlling it, actually, I will talk about in the memory management. Basically, we can control and restrict with the config files actually. But MongoDB is a good thing with the Mongo is it will occupy all the memory at one peak hours. But if it is does not using, if the peak hour or peak load is gone, if the OS is required the memory, it will give back if it has a free scope in the memory. We'll see that we can find what is the memory, how much memory it is locked, how much memory it is used, how much memory as free at the moment. The free memory we can release to the OS manually.
Oh,
We'll see that in the memory management.
sure.
So with MMP1, MongoDB automatically uses all the free memory on the machine. System resource monitors show that MongoDB uses a lot of memory, but it is dynamic. If the another process suddenly needs the half of the server RAM, MongoDB yield the cache memory to other process if it is free. If it is free, there is a condition. See, if another process suddenly needs the half of the server RAM, MongoDB yields the cached memory to other process if it is free. This must be mentioned actually. No compression of data and index and locking at the collection level, not document level. These are very big disadvantage, not small, very, very big. No compression is a big disadvantage, and lock at collection level, you are doing one write, it will lock complete collection, which is very bad. And there is no concurrency with that kind of locking model. Journaling with MF storage engine, like in this process, write operations occurs in MongoDB, which creates the changes in the private view. First, all the modifications will run on the private view memory. The first block is memory, and the second block is a disk, journal disk. After a specified interval, which is called journal commit interval, the private view writes these operations to journal. This is what it is talking about. The private view writing into the journal. Good enough. Disk in the disk, basically the journal files it. Once the journal commits that happens, MongoDB pushes the data into shared view. From here to here it will pushes there, and from there the maximum data, how much data is journal is only 2 GB. It is not 100 GB anyway, no need to run. It is not going to occupy all your RAM for that. Once the journal commit happens, MongoDB pushes the data shared view. As part of the process, it gets written to the actual data directory from the shared view. As this process happens in the background, the basic advantage is that we have reduced the cycle from the 60 seconds to 200 milliseconds. See, in the MRB1 architecture, if we are writing the data to directly data file or through, it does not, there is no way to explain this method. You have to follow this two-phase commit only. This is how the architecture is made anyway. In a scenario when abruption occurs at any point of time, a flash disk remains unavailable for 59 seconds. Keeping in mind that existing data in the journal directory writes the operation, then the next MongoDB starts. It basically reveals that all write operation locks in the locks and writes into the actual data directory from the journal. So it is the say statement that if data some reason uh, uh, it is all of a sudden it went off, all of a sudden it did not write all the data from the journal, or whatever the data is not written to data directory, the data directory is responsible, go on contact and pull off the data what is having the gap. The recovery he will happen with the journal only. The recovery is same like white tiger only except that two-phase commit, everything is same. It is important to know that journaling was disabled before 2.6 version by default. Right, this is another important point they might ask you. If you are running the 2.6 MongoDB version without journal enabled option in the config file, it will not create the journal. You have to explicitly mention under the storage, journaling enabled. You have to add something called, come on, quickly, cat, etc. If you read, there is a storage. Under the storage, you have to add journal enabled true. You have to add extra tag. If you add that one, it will create the general file. If it is 2.6, 3.6 onwards, general is by default. By default. So this is also an interview question. In which version White Tiger is introduced? I said this point. It's a question. In which version White Tiger storage engine is introduced?
3.0.
3.0.
Very good.
Yeah,
3.0.
3.0.
In which version White Tiger is a default storage engine?
3.0.
3.2. These points are important for the interview. And also, general is default disabled till 2.6. General is auto enabled from 3.0. This is also another important point in the interview question.
For MMAP.
Not only, yeah, of course, because there is no storage, White Tiger storage engine in 2.6 basically.
Right.
So it is definitely a map V1 only. Right. So this is we discussed already. So last one is something storage engine in memory. What you wanted to mention is engine. If you need a mmap v1 instead of the White Tiger storage, under the storage, I was reading this one, right? Under the storage, you mention extra tag called engine in memory. Basically in memory we discussed already, but I'm just talking about this. In memory is definitely not something you do implement. I don't think people implement with the Mongo. Mongo is a intensive product. You get lot of data into it. It is made for that kind of architecture anyway. Okay. So in memory, something becomes very costly because you definitely have to go with the replica set configuration. Two are in memory, one is a data disk. Wherever the data disk is writing, that is an ultimate protection for the in memory configuration. Starting from MongoDB Enterprise 3.2, it is not there before 3.2. This is also another interview question they will ask you. So in-memory storage engine introduced in 3.2, that too it is available in the enterprise, not in the community. The in-memory storage engine is part of the integral part of the general availability in the 64-bit builds. Other than that, some metadata and diagnostic data will be written to the disk anyway. The in-memory storage engine does not maintain any data on the disk. The collections data it won't maintain. It will maintain the journaling. It will maintain the what diagnostic data, health data, including the configuration data, indexes, user credentials. Everything is in the memory. By avoiding the disk I/O, in-memory storage engine will allow for the predictable latency of the data operation. It will give a good I/O performance because it does not need to write the data into disk. Write operations. 1 minute, guys. We're done. Write operations that will specify the write concern journal are acknowledged. Journal acknowledged immediately. So there is no journal. First of journal acknowledgement, it will write into the disk and give the confirmation anyway. Journal should be there for the recovery. But thing is, with the in memory, everything is in the memory. It will be gone if the system is rebooted. As simple as it is. But how you recover? Through the replica set. When a MongoDB instance shut down or shutdown command due to the system error, recovery of in-memory data is impossible. Data is lost. So for that reason, I discussed separate architecture for that. You guys remember, I guess. I picked up yesterday class. Yesterday means last class. If you see 3 architecture and 2 dependent on the memory to memory synchronization. This is a memory. This is a disk. So whatever you write memory to memory, it will write to the disk. If in the event of both the servers are lost, you have the data in the disk. This is ultimate protector for this data. You had to follow this architecture for sure. This is a memory. Okay, this is a memory. This is also a memory. This is a disk. In the both the cases, servers are lost. This is the only the ultimate protection for the data. But you need to maintain the replica set mandatory if you're going with the in memory. That's all about the storage engine architecture.
One memory server and one writing to the disk instead of, why is it mandatory to have another in-memory server?
Another means if this gone, if you are keeping disk will delay the performance. What you are expecting here, you don't get the expectation there. You
Right.
need you need the same performance. So only memory can give you. So
Yes.
it is another performance node you having it. You can keep one memory, one disk also, but when this is gone down, this is a primary. When this is primary, you see the drastically bad performance. Why? Because it is from the disk. If you
Okay.
wanted to see that performance, you need one more memory in memory storage engine.
Okay, got it. Yeah, makes sense.
Yeah, it is like that. So that's all about the storage engine. Storage engine questions, most of the question, definitely question will be there in the interview. What type of storage engines we have? What are the advantages and disadvantages? Like the main disadvantage with the MAP1, no compression basically at any level. Like you talk about the collection level, like data indexes or anything, and it has disadvantages that lock is at document level, which is not good. Storage engine giving the lot of advantages. First, compressing the data, which is very important for the data management in the background, the disk management, storage management. Next thing is it can support the concurrent transactions on a single collection by using the MVCC, multi-version concurrent control. So whatever the data you are modifying, that data only will be blocked. The rest of the data is open for the transactions, for other transactions on the same collection, right? So this is what about the storage engines, guys. Very generic question they do ask on this one. How does the recovery happens in the Mongo? In the Mongo get rebooted? You have to explain that. So if the journal is enabled, it can be MAP1, it can be anything. Journal will be there. If the journal is enabled, you have to start with this word. If the journal is enabled, all Mongo transactions will be recorded in the journal. Even if the Mongo abruptly shut down, Mongo will recover all the pending transactions, the last checkpoint from the journal file. You have to tell this point. Someone asks you, how does Mongo recover the data in case of abrupt shutdown? It recovers data from journal. At least that word must become. You have to tell that word, journal file. And if he ask you give more explanation, you go in detail of it. Like all transactions first write into the journal, then only it will give the confirmation to the application. Even the system is shut down, that means that we have whatever the data is committed in the system, we have in the journal. Journal will help us to recover right from the last checkpoint to till the current data, so that you don't see the data gap kind of. You give
So
some
there is
explanation.
no journal concept in memory at all.
In memory, even you're keeping the journal does not make sense. Why? Because where do you replay?
Yes, that's why. Because everything is in the memory, and if there's any shutdown of server, it is gone. So there is
Right.
no concept because since it's gone, there is no journal there. That means.
Right. Actually, one more thing I did not discuss quickly. See, one more thing. If you would have asked that question anyway. See, this is a primary going all the rights, and this is down. This picked up because it has all the data. When this comes online, it does not have the data, right? How it will sync up if this gone? We only this have the availability. No, replica by default. If you don't have a data, it will automatically sync with other copy when it comes online. If it is a physical data disk, if the data gap is there, it won't sync. But if you don't have anything, it will sync right from the beginning again automatically. In memory, all the time it runs without any data, only config file will be there. Every time it comes on, it will sync all the data memory to memory what it has, 100% data automatically. Replication is automatic sync if there is no data in the another secondaries. That scenario based question, maybe I'll explain in the replication itself, not now. This is all about the in-memory, guys. And so this is all about the storage engines. Tomorrow we'll start the crude operations, practicals, lot of practicals. Anyway, we have some architectures going forward, like technology architectures, how it is going to work. That also will come, but tomorrow we'll start the crude operations. Okay, crude means how you deal with the data. Like, see, MongoDB is not just for the archival; it also OLTP. How it is OLTP? That is what is the next module. Any questions? Before I stop? Fine.
So what is the best practice